Welcome to this web lecture on mitigating transport emissions by adapting operations. We really have to reduce transport emissions because transport contributes to 20% of the global GHG emissions, and it's one of the only sectors where both the absolute and the relative share of emissions continues to increase. One way that we can reduce transport emissions is by cleverly adapting the operations and tailoring them to the actual customer needs. So what we can do, for example, is we can, instead of providing a one-size-fits-all solution, differentiate by customer. So for example, this customer says, I would like to have my parcel as fast as possible. This customer says, I want cheap delivery. I don't care if it's today or tomorrow, but I would like it to be cheap. This customer only accepts deliveries between 10 and 12. And this customer could pick their parcel up somewhere. If we try to find a solution for all four of them together, that would of course be very expensive because we would have to deliver for all of them between 10 and 2. We have to deliver to all of them tomorrow. And at the same time, we shouldn't charge them anything for it. So this is going to make our life extremely hard, extremely difficult, and it's also going to introduce a lot of emissions, a lot of unnecessary emissions, because if we plan cleverly enough and plan sufficiently in advance, we can find a route, we can find a delivery scheme where we deliver fast to one, cheap to another, within this very tight time window to the third, and where we maybe deliver to a parcel locker instead of directly the house for the fourth one. So if we try to find one solution that does all of these things simultaneously, that's going to be difficult. But tailoring them to the individual customer need is not going to introduce that much additional cost. It's going to allow us to reduce emissions, and it's actually going to make those customers happy. Why are we not doing that on a regular basis? Relatively simple. We have to first understand what these people are doing, what these people are wanting, what their preferences are. And that, of course, makes our operations a lot more difficult. But eventually we'll have to get there. We'll have to overcome these hurdles. Another solution for reducing emissions is collaboration. So if we, for example, have the green operator and the orange operator who are both delivering parcels within the city center, then both of them are going to introduce congestion there. They're both going to add a lot of emissions, a lot of noise, a lot of air pollution, and all of that while really having high costs for themselves. So what they could do is they could say, we're merging operations, we're outsourcing to the same third-party provider, or the green operator takes over everything for both. This would, of course, get a more efficient route, which also means that the costs are going to reduce, which also means that the emissions are going to reduce, the congestion, the air pollution. Or they could say, okay, we're starting to exchange requests. So you, green operator, are taking over these 2 of my orange requests, and you're giving me those 2 green requests instead. And all of a sudden, we still have 2 routes in the city center. We still have 2 trucks driving around there. But at least the total distance and the total emissions is reduced. Why are we not doing that on a regular basis? There's of course a tremendous need for coordination, a need for exchanging data, and a need for sharing revenues and profits, and all of that every day. And that is something that of course a lot of companies are not willing to do. But it is also something where we as academia can help, because we can of course develop algorithms that make these things a little bit easier, a little bit smoother. Another solution is time windows. And the reason why we need time windows can be seen in this example. So here we have the factory on the left, which would like to deliver to those 4 customers. And the way that they do it, they plan a route and then they execute this route. So far, so good, but sadly, 2 of these customers, which are now in red, were not at home at that point in time. So what I have to do the next day, I have to deliver again. And this delivering again is going to cost us a tremendous amount of emissions, and it's one of the reasons why the last mile contributes such a big share of transport emissions. So what we can do instead is we can communicate sufficiently small time windows to the customers that the customer can actually ensure to be at home at that point in time, or tell us, please immediately plan my parcel tomorrow instead of right now. So then, of course, the question is, who gets which time window and who assigns this time window? So if we look into supermarkets delivering goods to your house, then this is usually the customer who decides which time window they want to choose. So if you order, you're going to see a web page and it's going to say, okay, this time slot is still available, this time slot is still available, and this time slot is still available. And you can then choose which of these slots you prefer. And that, of course, means that you as a customer also have to promise to be at home during that time frame. There is other schemes. So for example, if you get a parcel to your house, then it's usually the delivery company that tells you, we're going to stand at your door in this time interval, please be at home. If we communicate the time window, then we of course have to communicate that sufficiently early. And that is also something that we as a university and we as researchers are currently looking into. So what I would like you to take away from this video on operational change is how customer differentiation can contribute to reducing emissions, how collaboration can contribute to reducing emissions, and how time windows can contribute to reducing emissions, but also why they're not taken up to as great of an extent as we might hope. Thank you.